To evaluate this number, to evaluate a number like this, we begin by separating variables. We begin by separating variables. In this case, we shall have the integral. So we separate variables and integrate. So we shall have the integral of dy is equal to 1 out of 1 plus cos of 2 theta d theta, and then its integral. Now when you reach such a number, so remember there is a 2. So when you reach such a number, you go ahead to simplify it first. So you can have the integral of dy is equal to 2 out of 1 plus cos 2 theta integral d theta. Now if you look at this, this goes for t substitution. T substitution is where we say that if you look at the denominator is a trigonometrical expression. It's a trigonometrical expression. So we can go ahead and say let, so here we let t equal to tan theta. Now when you let t equal to tan theta, we go ahead and differentiate t. So we get dt d theta is equal to sec square d theta. Yeah. So we make a d theta the subject. So when we make a d theta the subject, we have dt out of sec square d theta. So we have it. We are having d theta because we are going to substitute it there. So we are going to substitute it there. So now the next thing is to simplify 1 plus cos 2 theta. We are going to simplify this. How do we simplify it? We use the t formula for cos 2 theta. So we come and say 1 plus cos 2 theta is the same as 1 plus, now the t substitution, the t formula for cos 2 theta is the same as 1 minus t square out of 1 plus t square. Now simplifying this, getting the LCM, we have 1 plus t square, then 1 plus t square plus 1 minus t square. Now if you clearly see the t squares go. So when the t squares go, we end up having 1 plus cos 2 theta is equal to 1 plus 1, we have 2 out of 1 plus t square. Now this is what we are going to substitute here. So taking it back, this one when we integrate, we are going to have y. So we shall have y is equal to the integral of 2 out of, now this is this. So we have 2 out of 1 plus t square, then times, when we put back our d theta, we have dt out of sec square theta. Now when we simplify this, we shall have our y as the integral of 2 out of 2 times, now this is going to go up, 1 plus t square, then times dt out of sec square theta. Now we very well know that this and this, they are the same, because sec square theta is 1 plus tan square theta, which is equivalent to 1 plus t square. Now this and this, they will cancel, so therefore we have the right to take this and this down, also this and that. So we shall have y is equal to the integral of dt. So this means that our y can be t plus c. But they told us to evaluate it. They gave us y and then pi over 4. So when t, remember t is tan theta. So we shall have y is equal to tan theta plus c. Now we substitute in our values. So we have 1 is equal to tan of pi over 4 plus c. So tan of pi over 4 is actually 1. So we have 1 is equal to 1 plus c. This means that we have c is equal to 1 minus 1, and this gives us c as 0. Now after having c as 0, we put it back here. Therefore, our y ends up being tan of theta plus 0. Then, eventually, our expression becomes y is equal to tan theta. Now, when you simplify this and evaluate it at y is equal to 1 and theta is equal to pi over 4, it eventually reduces to y is equal to tan theta. Don't forget to subscribe. If you haven't subscribed, please subscribe. Share it with your friend if you have understood, such that they also understand this content. You like, share, and comment where you have issues. We shall be able to solve them. Thank you so much. We meet in the next. Thank you.